Hi everybody, welcome back to our 12.2 notes on exponentials. In this last section, all we're going to be doing is solving equations that are exponential. And for the ones in this section, they're always going to have be able to be written with the same base, okay? So it doesn't work for every exponential equation, but it's really nice when it does. So in general, here's the principle we're going to be following, is if you can write things with the same base, so a to the x equals a to the k, then the only way that those things are going to be equal to each other is when their exponents are equal to each other, okay? So that's going to be our first thing with all of these problems, is let's see if we can get them to have the same base, because if we can do that, we can set their exponents equal to each other and solve really nicely, okay? So the first example I have is 2 to the x equals 1/8. So I know that 8 is a power of 2. So I know that 1/8 equals 1 over 2 to the third, right? And if we have something in the denominator, that would have a negative exponent. So I can rewrite 1/8 as 2 to the negative third. So now I have 2 to the x equals 2 to the negative third. Since they have the same base, I know the exponents have to be equal to each other in order for both sides to be equal to each other. So my exponents are x and -3, so what I know is that x has to equal -3. That's the only way that they'll be equal to each other, okay? And you can plug it back in to double check yourself if it helps. 2 to the negative third equals 1/8, so we did great. Okay, let's do another one. In part B, I've got 25 to the x minus 2 equals 125 to the x. So 25 and 125 are not the same, but I notice that 25 and 125 are both powers of 5. So let's start with that, okay? So I know that 25 is 5 squared. So I'm just substituting that in. I'm just rewriting it in a different format, saying that 25 equals 5 squared, and it's raised to the x minus 2. Then 125 is 5 to the third. So now I'm going to have 5 to the third raised to the x, okay? Then what you're doing is with exponents, we're using the power rule, because I have an exponent raised to an exponent, right? So when you have an exponent raised to another exponent, we multiply those together. So I'm going to multiply these together, and I will have to distribute, okay? So that'll be 5 raised to the 2x minus 4 on the left side. On the right side, I'm going to have 3 times x, which would be 3x. So 5 to the 3x. Okay, now I've got it in the format where we have two exponentials equal to each other, and they have the same base. And if they have the same base and they're equal to each other, the only way that's going to happen is if their exponents are equal. So now I can write an equation with just the exponents, which would be 2x minus 4 equals 3x. And then I can solve for x. So to solve for x, I'm just going to subtract 2x from both sides. So now I'll have -4 equals 3x minus 2x, which is 1x. So I have x as -4, okay? And if you want to double check that, you certainly can, okay? So if you wanted to double check that, you would put 25 to the -4 minus 2, so that would be 25 to the -6th. And on the other side, this would be 125 raised to the -4th. And if you type both of those in the calculator, you actually get the same decimal for each one, which is really cool. Okay. Last one is 3 over 4 to the x equals 16 over 9. So what I'm noticing is that 16 is 4 squared and 9 is 3 squared, right? So that kind of relates back to that 3 and the 4, but they're flipped. So do you guys know of any way that we could flip them back? It would be with negative exponents, right? So this would be the same thing as 3 over 4, since they're both to the second, which is good. But if we raise it to the negative second, that's what switches your numerator and denominator, is the negative exponent. So I can rewrite 16/9 as 3/4 to the negative second. So now I have 3/4 to the x equals 3/4 to the negative second. So guess what x equals? X, which is my first exponent, is equal to -2, which is my second exponent. And that's it. Okay, and again, if you would like to double check, you can plug it back in. 3/4 to the negative second, that would be 3 to the negative second, over 4 to the negative second, which would switch things around, right? That'd be 4 squared over 3 squared, which would then be 16/9. And so that checks out just fine. So that's how you solve exponential equations, or at least one way to solve exponential equations, is try to get them to have the same base first. And sometimes that's going to take a little bit of work, but go ahead and try to get them to be the same base first. Once they have the same base, then their exponents will be equal to each other. Okay? Good luck with all of this, and I hope you guys have a great week.